Hello, everyone. This is section 2.8. Um, Again, before I start this lecture, again, I want to remind you guys about the homework. So the homework of the web assigned homework of section 2.3, 2.4, 2.5, 2.6 is due this coming Saturday at 11:59 p.m. All right, and again, since this is a Thursday lecture, right? So in case if you see any quiz assigned in this lecture, then it is going to be due the next day, means tomorrow, Friday, right? Okay. Anyway, so in this section is about related rates, or basically we're talking about the rate of change. So let's say when we say dx over dt, then what can we say when we have these kind of terms? So this means change or basically rate of change rate of change of x in terms of t. Okay, so we're saying that the rate of change of x in terms of t. Okay, so that's what the meaning of this. So let's say if we say dx over dt is equals to 2 feet per second, or we can even write it 2 feet per second like this, right? So that means the change is 2 feet in 1 second, right? Okay, so now let's do some examples. So the examples here, the first one we have here is, okay, so is this one. So, okay, so now here we have, okay, it says a ladder 10 feet long rest against a vertical wall. So, okay, so let's draw a graph. So it will be easy to see what exactly the problem is saying. So if okay, this is a wall. If I make a picture, so this is a wall, and there is a ladder that rests against this vertical wall. So let's say, okay, now this is a ladder. Okay, and if the bottom of the ladder slides away from the wall at the rate of 1 feet per second. So this is the ladder and this is the bottom of the ladder, right? So now, okay, let's draw the bottom line as well. So we can define, well, we can say this as x, this is y-axis, right? So that means it's saying, okay, it says that at the bottom of the ladder slides away from the wall at the rate of 1 feet per second. So that means this is sliding down to the right at the rate of 1 feet per second. So since we're looking this on x-axis, and this is sliding on x-axis to the right. So if it goes to the right, or basically here the length is increasing, right? If you see from this origin to here, now if you go to the right, it is increasing, right? So that's why here's, and the rate of change is on x-axis, so we say that dx over dt is 1 feet per second. Okay. And okay, here we also have one more information. It says a ladder 10 feet long, so this ladder is 10 feet. And also, okay, how fast is the ladder, or is how fast is the top of the ladder sliding down? So how fast the top means this one, right? The top of the ladder is this one. So how fast this ladder is sliding down. So how fast this is going down. So this means from origin, this distance is now decreasing, right? It's going down, it's decreasing. So anyway, we need to find that dy over dt. But we know that since it is going down, that means our final answer dy over dt must be some negative number. All right, so just keep that in mind. And now down when the bottom of the ladder is 6 feet from the wall. So bottom of the ladder is 6 feet from the wall. So this bottom of the ladder is 6 feet from the wall. So that means this x value here is 6 feet. All right, so now, okay, so that means we have dx over dt, we have dy over dt, we have this x value, let's say this is g. So basically here, what I'm trying to do is I'm trying to use Pythagoras theorem. So we know that by Pythagoras theorem, well, if I say if this is x, if this is y, let's assume this as z. So we can say that x square plus y square is equals to z square. So x square here is 6 square plus y, well, we don't know the y, just say y square, and we know g square is 10 square. All right, so now from here, now you can find, well, this is 36, so y square is 100 minus 36. And then from here, you'll get the y value, which is y is equals to, well, when you take the square root on both sides, the y you will get is 8, which is 8 mile, right? 8 feet, sorry. Saying 8 feet. Okay, so now basically we have everything we need now to find, okay, basically we are trying to find how fast the top of the ladder is sliding down. So how fast means basically we are trying to find something in this form where we need to find feet per second, how fast it is moving, how like basically we need to find, this is pretty much a speed, right? That we learned in the last chapter. So that's what it is exactly asking here. But anyway, so what are we going to do after this is basically we have all the values we need. Now, again, we can take this equation, x square plus y square is equals to, well, here we can just take the value of z, which is basically g, or basically g square, which is basically 100, right? So now after this, using this equation, now we can use implicit differentiation in terms of t. Okay, so if you guys remember the implicit differentiation, now we are taking the implicit differentiation in terms of t, right? So that means now when we take the derivative of this, we need to take the derivative of x, the whole thing, 2x, and then take the derivative of just x, which is, well, we can just write x prime, or since we're taking the derivative in terms of t, we can, let's write like this here, dx over dt, okay? Similarly, even for y, since we're taking the derivative in terms of t, so same thing, take the derivative of this y squared, the whole thing first, which is 2y, and then just take the derivative of this y, which is dy over dt. And when you take the derivative of a number, it's a 0. All right, now, so what we can say here is, well, we know the value of x. It's 6 feet, right? So 2 times 6, we know the value of dx over dt, which is 1, plus 2y. We know the value of y, which is 8. Well, we are trying to find the value of dy over dt. So from here, it's 12. From here, it's 16 times dy over dt. So then move this to the other side, divide both sides by 16. So dy over dt, you get negative 12 over 16, right? Or you can even simplify this, which is negative 3 over 4. And the unit here we get is, since we are finding dy over dt, so it should be feet per second. And the reason there is negative here is, well, since it's going down, so distance is decreasing. That's why there is a negative here. Okay. Okay, let's do this problem now. Again, let's draw a picture. Okay, so now a car is traveling on waste. Sorry, car A is traveling west. So west means this direction. So there is a car A, which is traveling west this direction at the speed of, let's say this is a car A, the speed of 50 miles per hour. Okay, and there is another car B is traveling north, and both are headed for the intersection of two roads. Okay, so both are heading, so let's say this is the intersections, and another car is, well, let's say this is a car B, and this is traveling north, means this direction, right? So this one is traveling this direction. Now this is traveling this direction, and this is traveling at the rate of 60 miles per hour. And at what rate are the cars approaching each other when car A is, okay, so car A is 0.3 mile and car B is 0.4 mile from the intersection. So this is car A is 0.3 mile and this is 0.4 mile from the intersection. All right, so now what we can again take here is, well, what we can basically think here is this is x-axis, this is y-axis, right? So let's just say this is x, and this one is 0.4 is, let's say this is y. Okay, and now at what rate are the car approaching each other? So we need to find at what rate. So basically that rate will be, if I say this is z, then if I find dz over dt, then this value will give the rate that are approaching each other. Okay, now, well, basically here we know x value, we know y value, we don't know the g value, so let's find that. Okay, so again we can say x square plus y square is z square, right? Using Pythagoras theorem, just like we did in the last problem. So here x is 0.3 square plus y is 0.4 square. The g square well, we need to find the value of z. So from here, we get 0.09 plus 0.16 z square. So then from here, well, the value here, when you take the square root and everything, the z, you'll get 0.5. Okay. Now after this, again, what you can do is again using use implicit differentiation. So again, we are taking the implicit differentiation in terms of t. Okay. So just like we did in the last problem. So again, when we take the derivative of this whole thing, which will be 2x times the derivative of just x, which will be dx over dt, plus again, take the derivative of this whole thing, which is 2y times dy over dt. And for this one, again, 2z times dz over dt. Right, and then, okay, so we know, okay, so here, since we are saying that this is x-axis, so the value here, 50 mile per second, we can say that dx over dt. And here this is traveling on y-axis, so I can say this is dy over dt, right? So, okay, so here we know the value of, well, x, which is 0.3. And dx over dt is, well, okay, so now here the thing is, okay, so just like I did here, I explained here, so here when it is sliding down, that means that the length is decreasing, right, from the origin. If it's going down, if you are calculating the distance, then the distance is going to decrease. Similarly here, when this is going to the left, or basically going to the intersection, this here, the length is decreasing. Okay, so that's why dx over dt here, we are going to consider negative 50 or negative 50. Let's not write this unit here, but the value is going to be negative 50. Similarly to y is 0.4, and dy over dt is, again, since it's going, or basically again this length is decreasing, so again here this is negative 60 is equals to 2z is, we got the g value here, 0.5, and dz over dt, that's what we need to find. And then okay, so I'm not gonna do the calculation part. I know this is something you can do it by yourself. You have everything, you basically you have all the numbers, and there is just this thing missing. And I'll just give you the final answer, which is negative 78. And again, since we are finding dz over dt, or rate of change, so that means it should be, the unit here should be mile per hour. All right, so you have to write these values as well. All right, definitely for the final answer. Here it's okay, even if you don't write the unit, but here it's a mile, right? But for the final answer, yes, you have to write the unit. Okay. Okay, that's all I want to cover for this section. Let me see if I want to talk anything else here. Yeah, that's pretty much what I want to talk from this section. Yeah, thank you. I'll see you on the next video. Thank you.